So I wonder something. So in some example we have discussed before, it is about vision, it is about gestural, so all related to vision, so no physical contact, right? So where the communication at the physical contact would be less culture dependent. So for example, if you are to carry a table together or to do some sewing together, where the different cultures really matter. I would guess not so much actually, but yeah.
And does this all mess up our human experiments if we have grumpy subject? But I mean, like, to give you some context, so just to bring it back to how difficult these things are to measure, right? I mean, depending on what, I mean, we all know this from human experiments in general, right? We have high variability, but things that we don't necessarily, that we might overlook or that we're not controlling for may actually be also affecting some of our measurements.
Mm. So in motor control studies, we should specify the culture, maybe.
And mood,
Yeah.
right?
But maybe
Well, yeah, I wondered that. So sometimes, so I did quite a few studies in Japan, and probably Japanese students are more obedient than European students. And so I wondered whether my result would still be valid in another culture sometime. Yeah.
Yeah.
I mean, I think we also, again, just in the spirit of enhancing human robot interaction, we probably need to also distinguish between, let's say, variation of the targeted functional movement that we engage in or want to improve, but then human behavior is overlaid with a huge number of seemingly unnecessary gestural components that don't necessarily belong, so we think, belong to the task at hand. And maybe one could, that is symbolic cues, at least within a cultural context, one could add some basic cultural cues and overlay it to the otherwise targeted task of interaction.
Yeah.
I mean, yeah, I think this probably was brought up earlier. I think maybe it was, yeah, Eric mentioned that, right? So then, summarizing human behavior in terms of a single cost function is hard, right? I mean, it's, or maybe not. Yeah, it's just challenging, right? Um, and it does it, and I think this is also part, to get back to the bio inspiration. I mean, that's also part of why it's really hard to extract information from humans, and or why you don't necessarily maybe want to put exactly replicate human behavior on robotics systems, right? That maybe we can just give them simpler objectives, and they don't have to deal with the stresses or the millions of things that are running around in our human heads, right? And then we do a lot of things, like you said, like that are or that our conscious mind might not find necessary. Maybe subconsciously, they are necessary, right? Moving hands and things like that are maybe important for communication cues. Um, but we don't really have a good sense of, like, is this optimal? Is this optimal, right? In terms of how we behave, like in human behavior, that's not clear.
Yeah, in terms of the like optimal walking of human, I'm working on the robotic prosthesis, and like in short term, uh, like it's like what is the optimal walking? It's a very like big question, I think. Like in short term, we all have some compensated walking, okay, to minimize some energy expenditure. of ourselves. But for example, when we are working with the robotic prosthesis, they try to walk as much, try to walk to minimize their like energy, but then resulting in some like asymmetric walking. And in long-term use of that asymmetric walking, it could affect some secondary impairment to the residual bodies, right? So in that sense, it's not optimal. But in short-term use, we can say it's optimal because it minimizes the energy of the user, right? So I think it's really hard, and I want to raise some interesting word, trust, because like since the robotic prosthesis is a part of the user, and their that trust to how much trust do you have in this machine is really affects their behavior. Because if I'm not trusting on this device, they uh, they they don't try to put their weight, a full weight on the machine, then it results in some asymmetric walking because during their walking they have more weight on their residual but limb. So I think in in terms of the physical interaction of the prosthesis and human, we can measure that how much weight do you have on the prosthesis. We can it can be related to how much trust do you have in this machine. I mean, it's pretty hard and it's pretty interesting uh, topic of the human and robot interaction.
I mean, I think you're exactly right. And it reminds me of the videos that Neville would show of the arm prosthesis, where I think was it Brian the subject in those videos? You have this impedance controlled prosthetic limb, and and it was a 2-link arm. But what's cool is that you see the subject applying forces onto that arm, leaning as though it was actually their limb, and you could see that there wasn't like the same level, like they weren't necessarily acting cautiously, right? And so I mean, I think that brings up, I think, a whole other point of how do you quantify the effectiveness of an exoskeleton device or a prosthetic device, and is it always the optimization? Is it metabolic cost? Is it comfort? What is comfort? Those types of things. So I agree that I think like this idea of how do you quantify the effectiveness of an interaction is just still an open question. What does it mean? What is a good interaction? And I think actually, man, it's been a few hours. Is that, were we talking about that a little bit in the beginning too?
So Etienne, have you tried to quantify that in any of your human-robot interaction tasks, either trust or effectiveness, because they're interrelated, by looking at how much a human allows the robot to do a task that's being done cooperatively?
Rick, sorry, can you tell again?
Yeah, so Willem mentioned this idea of trust, or Megan called it, effectiveness of a human-robot interaction. And have you tried to quantify how much humans trust a robot during a cooperative task?
Yes, we do. Yeah, we do. So for example, so we have, for the people, so we study human-human interaction via 2 robots, so you can modulate the interaction as you want. And we have a model of the human interaction, so that make a model of the partner and then use it to extend the sensing. And we use that robot. So we did a study where we compare haptic guidance this robotic partner and a human partner. And we find basically that human, so you make a questionnaire and you make metrics, so smoothness and other metrics. And you find basically that people notice very well that haptic guidance, the trajectory guidance is completely different. They find it's completely different. They cannot differentiate. They cannot tell which one is which one between robot partner and human partner. But when you look at their behavior, they behave a bit different with a robot partner as with a human. So that's a bit something I wanted to say relative to Megan. I mean, so you make questionnaire and you get clear answer from the people, but it doesn't mean that what they feel is what they do. I mean, they are more clever than they think, in fact. Or what comes to the consciousness is filtered and maybe only a small part. So and okay, so another thing is that when you compare, so you ask them what they prefer, and basically human typically prefer trajectory guidance because they are lazy, and not only because they are lazy, also very clearly humans are very sensitive to whether the partner is predictable or not, and they don't like something that is not predictable. But it doesn't mean it's better to do a robot that is very predictable. For example, for learning, as we know, if you just put trajectory guidance, you would relax, so you would not learn. So, but basically, we don't like unpredictable interaction, and so yeah, that's. So yeah, so there are two ways to measure. So you can measure through metrics. So interaction force, smoothness. This is so objective metrics, and you have questionnaire. And in the questionnaire, you can ask not only whether they like, not only whether they are comfortable, but you can ask about specific things. And then sometimes you find funny things. So for example, we found that when you put a delay between the people, then they detect this delay even with 20 milliseconds. However, in this case, the performance is not different, but they are very, very sensitive. So so you can ask question in a way to understand what they perceive. And so indirectly get information about how they perceive, yeah.
May I add something on this thing of trust? Yeah, okay. I think it's I wanted to say that it's very interesting. I think that this aspect of trust in prostheses and also in exoskeletons where the device or the robot became part of the user. So in that case, I think it's really important to have trust and also understand properly how the device will behave because it's part of yourself somehow. And as Hong was saying about in lower limb prostheses, considering how much weight the user put on the prosthesis, I work in upper limb prostheses. And so in that case, for example, in my experiments where I use impedance control in upper limb prostheses while doing different tasks, for example, handshaking or with other users or passing objects from the prosthesis to the hand of the other user, one of the aspects that we study or check for this aspect of trust was the visual feedback that the prosthetic user was doing during the task. So how much she was looking at the prosthesis while giving the object. And also, for example, adding a cognitive task. So for example, not only passing the objects, but also speaking or mentioning, like, I don't know, like maybe speaking and explaining a story or whatever. So you can count the number of words, for example, that this person is able to say while is doing a manipulation task. And in this way, you can also somehow study how much the person trusts the device, because indeed it's capable of doing two complementary actions at the same time. And nothing. I just want to mention because I think it's interesting to also somehow evaluate the controller that is inside of the prosthesis and how well this is embedded by the user.
Okay.
I think that's, yeah, because ultimately, again, like when you think about how we want these devices to work well in the real world scenarios, and what is it that we want them to do, right? It's one thing if you give somebody a specific, if you give them back a capability, but if then they have to, like you said, like focus and they can't multitask, or it hinders, other abilities, then it's not going to be as successful. So I think, yeah, especially when it comes to thinking about what do we want, what is the end goal, or what's the user criteria. Yeah, I agree that those type of examinations are really important.
Just to add on, so when we talk about trust, how much of it can we actually design for, and how much of it should we should just call it quits and say, like, it's up to the therapist to train the user and develop that trust? So, like, how do you differentiate between the two? It's probably a very vague question, but it's, I can design impedance controllers that are maybe human inspired or bio-inspired for a prosthesis. And there's a lot of arguments that, yes, it's going to be a lot more comfortable because the user has more interaction. And they might develop more trust. I can add haptic feedback sensors to, for sensory substitution, and also get a little bit more trust. But at some point, I need to say, okay, enough is enough. The therapist has to figure out how to develop that trust even further. So, like, where do we call it quits?
I just think that's a great question, but I don't know.
So it seems like there's a lot more than like physical, like in the human robot interaction, there's something more than physical and human robot interaction. But because I think our discussion is also about like physical human robot interaction, I do have one more question to ask. It's about stability. So I think we mentioned about like how humans are stable in performing like tasks, and impedance control helps like stable interaction, following the what is that, like renowned notion of passivity. But then, as previously mentioned, if we change K, we can also dissipate energy, meaning that if we change K stiffness, we can also inject energy, violating passivity condition. So we do use like variable impedance, or we use like adaptive stiffness or adaptive controller, adapting parameters or varying parameters like during the tasks are executed. Then how do we guarantee stability of the given like design controller before like can you predict or guarantee stability without, like, maybe you can just demonstrate and see, oh, it's stable, but is there a way to quantify it, or is there a way to like calculate it? I think this question goes to maybe like Professor Brown or Burdett, who did like adaptive stiffness or variable stiffness.
Yeah, so very interesting question. So in a way, as you mentioned that, and it's a good point, that when we change stiffness, we can add energy. That's right. But does it need to be the case? So that is really kind of the fine point. Can we change stiffness without adding energy? So one simple example is if the spring doesn't store any energy, we can change stiffness without adding energy. So the system remains passive while we have an impedance change, a stiffness change. So in this way, the two don't exclude each other. We could have a passive system where the stiffness changes. Now, whether this is the only way to kind of change stiffness passively, probably it is not, but this is one way to do it. So the main point what I wanted to make is that changing stiffness is not excluding passivity.
Well, yeah, I think that's a great point. Maybe like also Professor Burdett, like when you did your adaptive stiffness controller during like interaction tasks, was the stability of this coupled system was one of the consideration or not? And maybe like another, but while Professor Lee is not here, we also have seen that negative damping, I think definitely it is not passive anymore, but it also helps like tasks to make like be agile. And then we were talking about like what is the good interaction. So sometimes it seems like making the robot passive seems maybe not the best way. Well, I don't know. Like I don't have a of course definitive answer or like argument, but like seems like there are some approaches to make the robot not passive or active. That sometimes helps, but would it cause an issue, or would people regard it as a good interactive devices or something like that? I maybe this is like quite an open question, but I think it is interesting to think about.
I don't know actually how to answer to your questions, but I think maybe some of the thing you mentioned, maybe you might be able to check some works from the DRR and also the University of Twente, for example, about how they make sure the stability while they are doing implementing the variable impedance control basically. There are some works also for the multiple tasks. I think you can maybe check the Alexander Dietrich and Christian Ott's work, and also the Stefano Stramaccioli's work. So they work a lot on this energy, the tank-based approaches to ensure the stability for the variable impedance. So I don't know. I think maybe you might be able to check some of the works on these issues.
Yeah, I guess like one like question that pops up in my mind is, I think, like as a summary, like is it the best way, like should we always make the robot passive? That's, I think, and is it always the best way to do? I think that's kind of one question that I don't have a like definitive answer for right now. But thank you all for like the valuable comments.
So actually there's a nice paper that establishes a stability theory for variable impedance using the Lyapunov functions. And it shows that you really, for robots, and it actually shows that you cannot just think about the value itself as having a positive or a negative damping or stiffness. You also have to worry about the derivatives of it. I'm just going to share the link of the paper. It's a very interesting one if you have an actual controller that you can derive and look at the derivatives of your stiffness and damping. But I think it's far more complicated than just looking at the value at one joint and say I have a high stiffness or damping, and that guarantees stability.
Okay, so unfortunately I have to interrupt this very interesting discussion because we are running out of time. I would like to thank you all very much for attending this session. It was really an interesting discussion, and I think we might try to propose this topic again in next conferences. Of course, if there are some other questions from attendees, now it's the time. Otherwise, we can move to the poster session after grabbing a coffee. No.
Thank you
No?
all for being like present here.
Yeah, definitely. Yeah.
Thank you so much.
Thanks a lot. That was great. It's a very nice discussion.
Thank you.
Thank you
you.
also from my
Yes.
side. Yeah.
Thank you all so much for talks and long discussion. This is like a 2-hour lab meeting, so.
Yeah.
Time flies. Time flies. I didn't know
Right?
that.
So yes, seriously, thank you all for coming and then presenting and also just being involved in the conversation. It was really fun.
Definitely. Yeah.
So.
Okay, see you all.
Yeah, and we can touch base on in the post that we can chat in spatial chat too.
Yeah, of course. Let's go to chill out.
Right?
Relax.
See you there.
See you there.
Bye.